So I'll be talking here about DP3T. So this is an initiative mainly by EPFL and ETHZ. And actually, it's the distributed privacy preserving contact tracing solution that everybody starts talking about now, and is being adopted in its philosophy. So I will explain this, and next week actually in Switzerland they will be doing trials. So this team that you see here has been creating these documents that you see in the GitHub and the solutions, but there's a much larger team behind it that's doing all the implementations. All right, so what is the goal here? Now, it would be great if we can lock proximity events so that we can use those to figure out when one is infected, who else could be infected, and so give notifications and as such be able to encourage people to maybe do a test. But how can we do this without sacrificing any privacy? Now, what do we really mean by privacy here? So let's talk about that first. So let's compare to the situation where we do contact tracing without a tracing application. So what does this mean? Well, the Dutch Health Center, the GGD, can ask infected individuals for when and who, and maybe where, they have been in contact with over the last 14 days. Now, with this information, you can create a contact history of time, identity, and maybe location, proximity events of all the infected individuals. Now, this is great because now one can create risk profiles for subjects that were in contact with infected people. And so you can indicate maybe you should go for a test. So this is very important. Now, all these contact histories can also be combined by the GGD. And this can be used to analyze how the virus propagates, whether additional measures need to be in place, where extra resources are needed, and so on. Now, healthy individuals remain completely anonymous to the GGD. They do not get information about someone who's healthy, with whom he has been in touch with. In fact, suppose I'll get sick, say, the 1st of May, and I'll stay sick for 1 month, then the GGD does not know anything before the period that I was contagious, and will not know anything anymore after the period I was claimed to be better. So the only information here in green is about what can be extracted from the combination of contact histories of infected people is revealed to the GGD or the government. Now this is very important.
There are
social graph
issues, Martin. So maybe you
everybody in the Netherlands needs.
Maybe you could repeat your last sentence.
Thank you. Yeah.
Yeah. There's still some connection issues.
What is important is that. Can I continue?
Yeah, I think you can continue. Yeah. I think it's better now. Yeah.
Right. So, well, let me repeat what this green sentence is about. So, it's very important to reveal information about what can be extracted from the combination of contact histories of infected people to the government. Because if you would reveal all the contact history of all the people, healthy and infected people, to the government, then there's a social graph that can be extracted with a little bit of extra help. Identities can be associated to that. And that's not what you want, because that can potentially be abused, and that will actually can hurt or damage democracy. So can we automate contact tracing, right, by using a tracing app without leaking more privacy than what is stated here in green? So that's what we talk about when we talk about privacy preserving. Now, of course, we want to do better here than what the GGD can do. So we want to have quick notification with small number of false positives. Now, let me explain the mechanism that DP3T is using. It uses Bluetooth anonymous exchanges, and it works as follows. So every single person in the Netherlands, hopefully, would have installed on their apps, if possible, right, on their devices, an application that constructs what we call a keychain. Now, when you look at the top here, you see a seed, a key, SKT-1 belonging to day T-1. And by using, in practice, a hash function, you forward this key to a next seed, a next key called SKT for the next day, which is called SKT. And then you forward it again for the next day after that. Now, these are, the idea is that these are one-way functions, so knowing SKT will not give you any information about the previous day, but you can reconstruct in a one-way forward manner the future days, the keys and the seeds for the future days. Now, given that seed for day t, you can use it in some pseudo-random number type of methodology to create a whole bunch of IDs. Say every 10 minutes during the day you want to get a new random, pseudo-random ID. So these are not linked to your true identity, right? But these are just IDs that you're going to exchange when you are in touch with another device. You do that over Bluetooth. So device A and device B are close in proximity, and some of these IDs will be transmitted to device B. And device B adds these to its log of all the IDs that it has seen over the previous days, the current days, and so on. So it logs those together with their timestamps. So in this case, say ID 7 up to ID 13. But now suppose that the owner of device A notices, oops, I got corona. So goes to the doctor and say day T is the first day at which this owner could potentially be contagious. Now at that point in time, it would be great to know his seed. So there's a voluntary question, you don't have to, but if you want to share, you can share your seed for that day to the GGD. Now, the GGD is going to broadcast all the new seeds of infected people to everybody in the Netherlands. So what's happening now is that this device B, for example, can now use that seed, that key SKT, to actually compute in a forward way all the seeds for all the days up to now, up to the current day. So SKT, SKT plus 1, all the way up to SK now. Using those, all the IDs that belong to that particular owner that is related to SKT can be reconstructed, which is denoted in this new oval that appears on the screen. And now a match can be seen potentially. So if there is overlap between the log that was stored on device B, depending on how much it is and so forth, you can do some local risk scoring. Depending on your risk related to some threshold or some policy related to that, you can use that or to show that you need to go in for a test. That's the main idea. But now let's have a look back at what is privacy here. Well, clearly, when we look at the GGD, they get to see those keys, right? The SKTs. And they can construct everything that happens after that, like all the future keys, all the way up to SK now, and all the IDs related to that. That's also what they could have done in the past without the app. They cannot look into, they cannot reconstruct the previous seeds, SKT minus 1 and so on, of that same person when he or she was healthy. Now, of course, when you're declared to be healthy again, you should remove the app and reinstall it with new seeds, right? But that's a side remark. But what's the problem? Every single being in the Netherlands will be able to see that database, right? Because it's being broadcasted. So not just the GGD, but also all the other people in the Netherlands can create a proximity graph of infected people. And this may still leak quite a bunch of privacy to those who do not need to know this. So as a second enhancement, DP3T proposes to not just store these SKTs, but the GGD should use the SKTs to construct essentially these, redo this computation by device B and compute all the IDs, and then put them after hashing into a cuckoo filter. And the idea is that if you broadcast those, say every 4 hours a new filter, then device B can do easy membership computation, so can create information about how much overlap there is, but is not able to reconstruct, or at least it's hard to reconstruct a proximity graph for infected people. Now, if you look at the Google and Apple proposal, then we noticed that they propose, I saw that yesterday, they propose just the basic solution without the cuckoo filter. So it's very important if the Dutch government decides to go with, say, Google and Apple, that they also introduce that enhancement. DP3T is a great piece of documentation. You should definitely have a look at their website if you want to, and look at their documentation. There's a lot more details and even some more enhancements for some niche types of specialized type of attackers with certain kinds of resources that they can also prevent. Now the question here is, what about the effectiveness, right? So all of this depends, the effectiveness of such an application depends on the voluntary adoption by the Dutch people. Now that means, of course, that it has to be privacy preserving, but also the public needs to understand what that means. And then is more acceptable of using such an application. It should support your mobile platform. It should not have too much battery consumption. There should not be too many false positives, because otherwise there may not be enough test capacity. And if you are going unnecessarily into quarantine, then that's not a good thing. The Bluetooth itself may not be too reliable on figuring out proximity. You want to have quick notifications to do better. And last but not least, also you may want to worry in the future about the denial of service attacks, and the apps need to resist, of course, hacks. So this is pretty much what I wanted to talk to you about.